Hi, I'm Aslan. In this STR8CHEM video, I will teach you on how to solve question regarding on topic friction kinetics. Let's have a look at this question. We have balance equation given to you, and the question wants you to determine the rate law, rate constant, and rate formation of CO2. Overall, we have three things that we need to do for this question. Typically, the question will give you a set of data, and inside the table over here, we have 4 series of experiments, and each of the experiment will have the information about the concentration of each reactant involved in the reaction above. Also, they will provide with you the initial rate. By using this information, we should be able to find what is the rate law, and after we have figured out what is the rate law, from there we should be able to find the rate constant value. So, how to find rate law is, first you are going to write the rate in front equals to K, and you have the concentration of both reactant raised to some power. K over here represent the value of rate constant, and X and Y here is the we do not know the power over here, so we need to represent the power exponential with any kind of alphabet. Over here I choose X, and Y you can choose other alphabet too. So basically we have rate equals to K, concentration HgCl2 to the power of X, concentration C2O4 2 minus to the power of Y. So this is our rate law equation. After that, for the second step, we need to find the value of X. How you do that is by comparing two experiments. So you need to pick which one you want to use. In this case, I choose to compare experiment 2 and 3. Why? Because when you compare experiment 2 and 3, you would be able to cancel out the concentration for C2O4 2 minus over here. And thus we will be able to work out the value of M. We can cancel out the concentration of C2O4 2 minus. Also, we can cancel out the K value, because why? K to every experiment is all the same. So when you have the same value, you can cancel it out. So we do the calculation. If you divide this value over here, you will get something value around 2. And when you divide 0.164 over 0.082 to the power of X, we will get the value around 2 to the power of X. So how to find X is, you give ln to both sides, you bring X into the in front, ln 2, then you find X, you will get ln 2 divided by ln 2, you get 1. 1 over here means that, therefore, first order with respect to HgCl2. After you find X, you need to find Y. It is the same as what we have done in step 1 over here. To find Y, you need to compare experiment 1 and experiment 2. Why I choose to compare experiment 1 and experiment 2, so that I can cancel out the concentration of HgCl2 over here and K over here. So you will get the value 3.2 exponent negative 5 over 2.9 exponent negative 4 equals to 0.15 to the power of Y over 0.45 to the power of Y. When you do the calculation, you will get 0.11 equals to 0.33 to the power of Y. So how to find Y? You bring the Y into the in front, you put ln on both sides, then you will get Y equals to 2. Therefore, 2 over here means second order with respect to C2O4 2 minus. So after you find X and you find Y, you would be able to find the value of K. So to find K, substitute any value from table to rate law equation. Rate law equation over here is this one. red equals to K concentration of HgCl2 C2O4 2 - 2. In this case, I use data from experiment 1. I just substitute the data from experiment 1 into the red law equation. Over here, I have 3.2 exponent negative 5 m as negative 1 equals to K 0.164 m times 0.15 m to the power of 2. Don't forget to put the unit over there. So we will have 3.2 exponent negative 5 m as negative 1 equals to K. When you times this one, you will get 3.69 exponent negative 3 m to the power of 3. So you bring K to the in front, you will get 3.2 exponent negative 5 to the power of negative 5 m as negative 1 over 3.69 exponent negative 3 m3. So when you calculate that, you will get the value around 8.67 times 10 to the power of negative 3. Don't forget the unit. You have m over here, you can cancel out. 3m over here, you can become 2. So you will have m negative 2 as negative 1. So you will be able to find the red constant value. Now we already done the first to find red law, second to find red constant. Now we will able to find the rate of formation of CO2. First thing first, you need to write down the differential rate equation for the given equation. The balance from the balance equation given, you should be able to write down the differential equation. Over here, I already done it. Rate equals to negative half dHgCl2 over dt equals to negative dC2O4 2 minus over dt equals to positive half dCl minus over dt equals to positive half dCO2 over dt equals to dHgCl2 over dt. So you need to identify what really the question gives. In this case, the question gives you the rate of disappearance of C2O4 2 minus, which is 2.2 exponent negative 4 m as negative 1, and the question wants you to find the rate of formation of CO2. How you do it is you just compare these two values. You know that the rate of formation, the rate of disappearance of C2O4 2 minus is equal to the rate of formation of CO2, and you have the value of rate of disappearance of C2O4 2 minus over here. So you just substitute this value into this formula, then you bring the 2 to the in front, you times, then you will get the value around 4.4 times 10 negative 4 m as negative 1. So you will get the value of rate of formation of CO2.